All right, let's jump straight into this explainer. We're going to absolutely master the exact workings you need to snatch up all 6 marks on question 17 from the November 2023 Edexcel Math higher tier paper. We'll be breaking down the exact wording the examiners are looking for in the mark scheme step by step.
Here's the game plan for today. We'll start by unpacking question 17, then dive into part A to prove the root. After that, we'll hit part B for the algebraic rearrangement, move on to part C for the iteration formula, and finally, wrap it all up with the acceptable final answers and ranges.
All right, section 1, unpacking question 17, specifically our core equation x cubed plus 2x minus 6 equals 0.
Moving right along to section 2, part A, proving the root. We need to establish that boundary between 1 and 2. Take a look at the exact exam prompt for part A. It's worth 2 marks and simply asks us to show that a root exists for our equation between x equals 1 and x equals 2. Notice you're not actually finding the precise root here. You literally just need to prove it lives somewhere in that neighborhood. To knock this out, we just need to execute 2 straightforward mathematical steps. We're going to substitute those boundary values directly into the left-hand side of the equation. First up, plug in a 1. That gives us 1 cubed plus 2 times 1 minus 6, which leaves us with negative 3. Next, we drop in a 2, so 2 cubed plus 2 times 2 minus 6, and that gives us exactly 6. Now check out the precise wording from the mark scheme for this first method mark, the M1. Just writing down that initial substitution, either x equals 1 or x equals 2, gets you on the board. The examiner isn't demanding perfection right out of the gate, they're rewarding your mathematical intent.
When we put these 2 results side by side, f of 1 equaling negative 3 and f of 2 equaling 6, the mathematical shift is super obvious. We've jumped from a negative number to a positive one. And hey, in a continuous function, the only way to get from negative to positive is to cross 0. That exact crossing point, that's our root.
But here's the catch for securing that C1 communication mark. The math alone isn't going to cut it. You have to explicitly write down the phrase sign change in your final argument. Just state clearly that since f of 1 is negative and f of 2 is positive, there's a sign change, and boom, therefore a root exists. That's exactly how you lock in that second mark.
Next up, section 3, part B, algebraic rearrangement. This is all about earning that next C1 mark.
The prompt here throws us a bit of a curveball, asking us to transform our original equation into a very specific fraction format for 1 mark. Basically, we need to completely isolate x on the left side, leaving us with a 6 over x squared plus 2 on the right. According to the mark scheme, there are a few acceptable pathways to prove this rearrangement, and you absolutely must show an intermediate step. You can't just jump to the final answer. Whether you decide to factorize the x first or shift the 6 over first, the examiners will accept any of these logical progressions listed to award that C1 mark. Let's walk through the most direct route. These 3 steps hit the examiner's criteria perfectly. First, move that negative 6 over to the right side to isolate the constant. Second, factor out an x from the remaining terms on the left. And finally, just divide both sides by the bracketed term, x squared plus 2. That leaves you right at the target equation. Easy C1 mark secured. All right, rolling right into section 4, part C, the iteration formula, where we actually estimate the solution. Pay close attention to the incredibly strict instructions on this one. We have to start exactly at our given x0 value of 1.45. We have to iterate exactly twice, meaning we calculate x1 and then use that to find x2. And the kicker, the final answer must be formatted to exactly 4 decimal places. Precision is literally everything here. If we map it out, it's basically a continuous loop. You take that starting value, run it through the formula, and get an output. Then you take that exact output, feed it right back into the very same formula, and that gives you your final estimate. It's a strict procedural progression from x0 to x1 straight to x2. And here is how the mark scheme breaks it down. You get the first M1 mark just for showing the correct substitution of 1.45 to find x1. Writing out 6 over 1.45 squared plus 2 guarantees you a mark. That gives us this big unrounded value of 1.462522851. Now, whatever you do, keep that long, messy number right there on your calculator screen. Because to lock in the second M1 mark, you've got to show that unrounded x1 value being fed right back into the formula to find x2.
The examiners are specifically looking for evidence that you used 1.462 something squared in that denominator. Do that correctly, and it yields an unrounded value of 1.449634937.
Finally, let's head into Section 5, Final Answers and Ranges. This is all about securing that ultimate A1 accuracy mark.
So, looking at our raw output of 1.449634, we need to round to 4 decimal places. We check that 5th decimal place, it's a 3. Since 3 is less than 5, we just round down, which gives us exactly 1.4496. That is the precise number you want on that answer line.
But here's a cool little detail from the mark scheme. It actually accepts any final answer that falls within a super tight mathematical range. So if you write down 1.4496, you get the mark. But interestingly enough, if you write down 1.4497, you'll also get the mark. It gives you just a tiny bit of breathing room. And this highlights a massive safety net built directly into the marking rules. Listen to this. If your unrounded working is visibly correct in your steps, but you totally panic on that final rounding step and make a mistake, the examiner will still award you full marks. So your underlying process really does matter just as much as your final answer.
We just successfully used iteration to find this root to 4 decimal places, but it begs a pretty fascinating question to leave you with. What happens to this formula if we start with a wildly different x0 value? Would it still magically hunt down that root, or would the math completely break down and spiral out to infinity? Think about that for a bit. Thanks so much for tuning into this explainer, and I'll catch you next time.